The average amount of stock ordered from a store is 444. 40 other stores were sampled, and it was found that their average was 430 with a population standard deviation of 52. At alpha is equal to 0.05, can it be concluded that the average differs? Use the p-value method. All right, so we got a two-tailed p-value method. So something to keep aware of is the calculator will give you the value for the total alpha, not for half of the alpha, which when you do it using the chart, you typically like to use only half alpha because there's no reason to go to the full alpha. So let's go ahead and find our H naught, our null hypothesis. That is going to be that the mean is equal to 444, right? Because it says right here that the average amount of stock ordered for stores 444. And then they want to know, can it be concluded that it's different? So that means the alternative is that the mean is not 444. And this would be our claim, since that's the one that we're trying to conclude. So claim. Now we're going to go ahead and identify the fact that it's two-tail. It's two-tail, we know, because it's not equals 2. So two-tail. Let's go ahead and get our numbers out of the problem here. So we've got that the mean, the population means 444. We're given a sample average of 430. We're told the population standard deviation is 52, which tells us that we're going to be doing a z-test. So this right here, indications of z-test. And we're also told that the alpha is equal to 0.05. And that n, the number of stores that we looked at, that was 40. All right. So from here, we can get our test stat. That's that z is equal to x bar minus the mean divided by standard deviation over the square root of n. You can look up this formula if you don't remember it. So our x bar is 430. Our mean is 444. And then on the bottom, we have a sigma of 52 and a square root of 40 for n. Now, we're going to do this using the calculator as well. So if you're unfamiliar with this formula, if you were taught just to use the calculator, you'll see how to do that. So we're going to go ahead, put this in our calculator. We have 430 minus 444. We're going to have another fraction right here. We've got 52, and then we're going to divide by the square root of 40. We're going to get out our answer, negative 1.70. It's not too big, so it looks like it'll be fine. From here, we can find our test stat, our p-value. So to find the p-value with this, right, it's a two-tail test, so we're only going to get 1/2 of the p-value. So this is the p-value divided by 2. And if we look up 1.7 in the chart, we'll go ahead, go over to the chart, look up negative 1.7 since the curve's symmetric, so it's easier to look on the negative side. Here's negative 1.7, and then we want 2. So we're going to go across like this. So we see that it's 0.04272. 0.04272. So we'll write that in, 0.04272. Our alpha was given to be 0.05, but we want alpha over 2 since this is only half of the p-value. So alpha divided by 2 is 0.025. And when dividing with decimals, it's always a good idea to just really quick double check because sometimes you might be off by a place. You might miss something. Like it's so easy to mess up decimal division, so just be careful. So we look at this and using the chart method, we're able to deduce that, hey, 0.04 is bigger than 0.02. So P of alpha over 2 is bigger than alpha. So we say P is greater than alpha. Therefore, do not reject H naught. We'll make the rest of the conclusion here in a second, but let's go ahead and do it using the calculator way. So when we look at this, we say, okay, well, We want all of alpha, so all of the p-value, so we could compare it just against regular old alpha. So we could take 0.04272 and double it, and we're going to get 0.08544. And this is regular p, and you can see that 0.08 is bigger than 0.05. We get the exact same conclusion. But I do that because let's do it with the calculator now. The calculator is going to give us the total. And we're only doing this because it was a two-tail test. So there's a reflected z-score above as well. So let's go to tests, z. We have statistics. We're going to put in our population average, which was 444. Our sigma was given to be 52. Our x bar was told to be 430. Our n was 40. And we had a not equals to sign. So we choose not equals to. We hit calculate. We get the exact same z-score of 1.7. Oh, hold the phone here. I think I looked up 1.72. It's not too important. It's still really, really close. We'll go ahead. We'll go back. We'll get the right ones. But you can see the p-value here. The p-value from the calculator is 0.0886. Now ours is a little bit off because I made that mistake. I looked up the wrong z-score only by a little bit, not that big a deal. Let's look up 1.70 here real quick. So we'll come back here, look up 1.7, and then we want 0, which gives us 0.04457. All right, so let's update our values. 0.04457. 4457. And again, it doesn't change our decision because I looked at a z-score extremely close to this, so it wasn't a big deal. But let's double this, and it will probably be closer to this p-value. So let's go ahead and get out of here. Whoops, I just meant to go back. There we go. 0.04457 times 2. And we get 0.08914, which if you were to round this, we get 0.089 both ways. So that would be the actual correct one. So sometimes mistakes happen. That's a good reason to do it two ways. You could catch mistakes like that. So you can see, there we go. Now it's a little bit different because we use the chart and the chart has some rounding error. Calculator is a lot more accurate, but you can see extremely close if we were to round. And again, since the p-value is greater than alpha, and remember this is the entire p-value, because if you look at the chart, you're only getting half of it for a two-tailed test, that is. So we double it. And then we look at this and we say, okay, well, the p-value is greater than alpha, so we do not reject h0 because the p-value is not in the shaded region of alpha. Then we say, since we don't reject h0, we could say something about the claim. Now, our claim was the alternative. We think that h0 is true. We have evidence to support that it's true. So that means that we think the claim is false. So that means that we do... Or we could say there is not sufficient evidence. I'm going to go ahead and move these p-value things down a ways. Sufficient evidence to support the claim. Now here as well, when we say this, we would say the claim that the average differs. And that's still a little too vague. That the average amount of stock ordered from a store differs from 444. That's what we're really saying. So you could tack on all that at the end if you want to be extra fancy and include it all. But that is the process here. So p-values don't need to draw a chart or even mess around with critical values because you're going to work with alpha directly, making it a pretty appealing way to do a problem like this. And that's how you would do it if you were given a two-tailed test. If you're given a one-tailed test, you would not need to do any of this dividing or doubling business because you would just have one side to worry about instead of two sides. If you have any questions about this, feel free to drop a comment, subscribe, and hit that bell icon for future videos, and we'll catch you in another problem.